Now we're going to look at our final case of decomposing partial or fractions into partial fractions. So p of x over q of x is our fraction, or q of x has a repeated irreducible factor. So it had a single irreducible quadratic factor, now has repeated irreducible quadratic factors. I missed that term last time I read it. So the partial fraction decomposition of p of x over q of x, when q of x has a repeated irreducible quadratic factor, and the degree of p of x is less than, there we go, q of x. So we have p of x over q of x is a1x plus b1 over this, our irreducible quadratic factor, plus a2x b2 over the same factor but now squared, plus dot 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 a sub n x plus b sub n over that same quadratic factor now to the nth power. So when that irreducible quadratic factor occurs n times, so you do it out this many times. And the key I want to point out, though, this numerator term is going to be just the linear every time, because this is a repeatable quadratic factor down below. Like if it was x squared plus 3, x squared plus 3, x squared plus 3, we would always keep this as linear up on top, but then we just change the power each time. So how to decompose rational expression that has repeated irreducible factors? Use the variable a, b, or c as the constant numerators over the linear factors and linear expressions such as a1x plus b1, a2x plus b2, and so on. For the numerators of each quadratic factor in the denominator written in the increasing powers, such as we have there, same process now, multiply both sides of the equation by the common denominator to eliminate fractions, expand the right side of the equation and collect like terms. And I don't really do that, I can look over there and see which ones are coefficients for x or x squared or the constant. Set the coefficients of the like terms from the left side of the equation equal to the right side. Create a system of equations to solve for the numerators. Look at this one. Now, right off we see x to the fourth, but if you think down below we have x, then this x squared plus 1 is squared. So that's like x to the fourth times x to the fifth. So the degree down below is more than the degree above. So we're going to start off with our x to the fourth plus x cubed plus x squared minus x plus 1 over x times x squared plus 1 squared equals, we're going to have a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared. And that's how we're going to break it down. So I'm going to multiply by this x times x squared plus 1 squared to clear out the fractions. So we have x times x squared plus 1. Actually, I just saw my boundaries. I think I just went beyond it. I think that's within it now. X squared plus 1 squared times x to the fourth plus x cubed plus x squared minus x plus 1 over x times x squared plus 1 squared equals x times x squared plus 1 times a over x plus x times x squared plus 1 times bx plus c over x squared plus 1 plus x times x squared plus 1 times dx plus e over x squared plus 1 squared. And we pull in our red pen and mark off the x's, those divide out, and the x squared plus 1 squared, those divide out. Over here, just the x's divide out. Oh, that was supposed to be a squared here. Okay, so in this case, an x squared plus 1 goes away, so the squared part, consider that gone. Then here, the whole thing goes away like that. And what do we have? On the left, we have x to the fourth plus x cubed plus x squared minus x plus 1 on the right. So it's a times x squared plus 1 squared. So that's going to be an x to the fourth plus 2x squared plus 1. So it's ax to the fourth plus 2ax squared plus a. Then we have our bx. It's going to be complicated. Bx times x squared. So I have a bx to the fourth. Bx times x times 1. So plus bx squared. Then we have c times x squared. So cx cubed. C times x times 1. So plus cx. Dx times x is dx squared. And then e times x is ex. So let's see what we have. Let's start collecting our terms. So for our constant, on the left I see a 1. On the right I see an a. And that's it. Hey, we got one of them already. Okay, so for our x terms, on the left we have a negative 1. And on the right, I have a c plus e. Okay, go back up here, make sure I got that right. And then I have for our x squared, we have a 1 on the left. And on the right, I have a 2a plus, and then we have a b plus, then I see a d. Then we have an x cubed. On the left, I see a 1, and on the right, I see a c. Okay. And then for our x to the fourth, on the left I see a 1, and on the right I see an a plus b. Okay, so we can start, this is coming together pretty nicely because we have c as 1 and a as 1. So we know a is 1, so if a is 1, 1 plus a is 1 plus b, 1 equals, excuse me, I said it completely wrong. 1 equals 1 plus b, so b must be 0. Okay, didn't expect that. And then negative 1 equals c plus e, but c is 1. Negative 1 equals 1 plus e, so e must be negative 2. Okay, that's good. So we know A, we know B, we know C, we know E, we don't know D. So we know that 1 equals 2 times A, which is 1, plus B, which is 0, plus D. So 1 equals 2 plus D, so subtracting 2, negative 1 equals D. So let's put it together. This came together kind of nicely. So that was an x squared, no, x to the fourth, plus x cubed plus x squared minus x plus 1, that's right, over x times x plus x squared plus 1 squared. It's going to be our a, which is 1 over x, plus, then we had a bx, so b was 0, so 0 times x plus c, which is 1 over x squared plus 1, plus, then we have dx, so d was negative 1 times x minus, or plus negative 2, so plus e, which is negative 2, over x squared plus 1 squared. So we can clean that up a little bit. So 1 over x plus 1 over x squared plus 1 minus x plus 2 over x squared plus 1 squared. So what I did here is I just factored out that -1 here. You could leave it as plus -x minus 2 or -x plus -2. But there is our decomposition. Okay. Hope you had fun with that as much as I did. So that's about it.